All right, last video now. We've got our two-way table done based on our problem up here. Our null hypothesis is going to be that there is not a difference between brain removal and standard treatment for seizures, dealing with epilepsy. All right, and the alternative hypothesis is that there is a difference. All right, so here's what we're going to do. Basically tells us how to do our test up here. So here's what we're going to do. In our calculator, we're going to go to a second matrix, which is right above the inverse button. We're going to go over to edit, and we're going to put in the size of our matrix. The size of our matrix is 2 by 2. We're only putting the data in. We don't need to put the totals columns. So we're going in our calculator. I'm going to hit matrix. I'm going to go over to edit. I'm going to edit matrix A. It's a 2 by 2, so I just type in 2, enter 2, enter. And I'm just going to type in my numbers 5, enter, 1, enter. Whoops, sorry, it should have been 15, enter, 1, enter, 21, enter, 39, enter. It always enters across. All right, there's my matrix. So now I'm going to second quit that. I've put it in my matrix. I've put it in matrix A. So the next thing I need to do is go to my stat test. It's going to be a chi-square test, which is letter C. Chi-square test. Hit enter. My observed is in matrix A. My expected, it will put it in matrix B. And I would like to draw this. Okay, drawing it will actually give you the chi-square distribution. The chi-square distribution looks like this. And it says that my chi-square value is 17.4879 and my p-value is approximately 0. Okay, so this being your chi-square distribution, we'll find our degrees of freedom here in a minute. If I, instead of doing the draw, if I just did stat test and if I did the chi-square test, and I calculate it, it gives me the chi-square, the p-value, and the degrees of freedom is 1. So it gives me all that. Now here's the mechanics that you would have to write down for step 3. The process you would go through, first you'd write down, at first glance it appears that there is a difference between the brain removal and standard treatment for the treatment of seizures. But this difference could be due to randomization variability, and actually this case sampling variability because it was a study. They're not real sure. We're not sure if it was a very good experiment, so either one would probably be fine. So we're going to do a chi-square test for homogeneity of proportions. We're going to let our alpha level be 0.05. All right, here's our null and alternative. Our conditions that we have to check. Our conditions that we have to check here, our conditions would be a random sample. Yes, it was a random sample. It said, it doesn't say it is, so we have to assume that in this case, or assume that they were randomly assigned to treatment. All right, and looks like maybe, we could say it says it was a study though, so we would assume that, 76 is less than all patients with epilepsy. And then finally we would say that all expected counts are greater than 5. Well, we have to prove that. So how do we get to our expected counts? Well, our calculator actually finds our expected counts for us. If we go to math, our second matrix, we go to second matrix, and matrix B is right there. And let's see, I'm just going to go to second matrix, and I'm going to edit I'm going to edit matrix B, and it just actually gives me, there's my expected values. So there's my expected values. I would need to write that down. It's 7.58 and 8.42 and 31.58 and 28.42. So you've got all of your expected values right there, and they are all greater than 5. So there's my observed, my expected. Okay, so now we've got our p-value and everything already, but we still have to write, like in step 4, we have to write our computation. So we would be writing that our chi-square statistic is still our observed minus the expected squared over the expected, and it's the sum of all of those. Okay, so don't forget that sum. And then we could say that our chi-square statistic is 17.4879. The probability that chi-squared is greater than that is equal to my p-value, which is approximately 0. Which, if I compare that to my alpha level of 0.05, that's less than that. So what I'm going to do is I'm going to reject the null, which means that I conclude that there is a difference between brain removal and standard treatment on seizures. All right, so the top of the next page just asks us a couple questions. Can we conclude that surgery is better? Or why can't we conclude? Well, we can only conclude a difference. Okay, chi-square testing is not good for saying one is better than the other. You cannot use a chi-square test to say one is better than, more than, greater than the other. Could you have done the problem another way? Yes, you can. You could have used a 2-proportion z-test for P of brain surgery minus P of standard treatment. Your null hypothesis would have been that the brain surgery minus the standard treatment is equal to 0. There's no difference, and the alternative would be that one is better. Well, that would mean more people have less seizures, you know. So this would be, you'd be looking at seizure-free, okay? You'd only be looking at that category. So the proportion of people who had brain surgery minus the proportion with the standard treatment, that would be greater than 0. And actually, in order to make it more like a chi-square test, you just want to do a 2-sided test, not equal to. Is it different from? All right. So you can do this on your calculator. You're looking at 15 out of 36 for P of the brain surgery and 1 out of 40 for the standard. So then you can just go stat tests, 2-proportion z-test, 15, 36, 1, 40, not, I'm going to do not equal to, I'm going to draw it. And there's my picture. It's my z is 4.18, so basically here and here. So the probability that your z statistic, probability that your difference in proportions is greater than whatever 15 divided by 36 minus 1 divided by 40 is, greater than 0.3917, is the probability that z is greater than, I just had that test in there, so I'll just call it back up again. The probability that z is greater than 4.1819, which gives me a p-value equal to approximately 0, which means I reject the null, because that is less than alpha. So I would make the same conclusion this way. All right, so when degrees of freedom is 1, degrees of freedom, we never really talked about that. Degrees of freedom, row total minus 1 times column total minus 1. All right, so I had 2 rows and 2 columns, so 2 minus 1 times 2 minus 1, well, that's 1. That's how we get 1 degree of freedom. Just a couple of notes down here. When degrees of freedom is 1, a 2 by 2 table, the test is two-sided. A homogeneity of proportions test is the same as a two-sided two-sample z-test for P1 minus P2. However, if the table is greater than 2 by 2, you have to use chi-squared. If the table is 2 by 2 and the alternative hypothesis is one-sided, you should use the z-test. Also, in doing a goodness of fit test, there are only 2 categories, or degrees of freedom 1. This is equivalent to a one-sample z-test for a proportion. So these are just other equivalent tests you can do if you actually want to make a better decision than a chi-squared test as far as what is better, one-sided testing. So you've got these 3 homework problems and this page to read. So I would also ask that you get on the website and go to the review area where you can AP exam practice area. AP exam practice area, and there's a multiple choice test link that you can do online, and I would like each of you to give that a try sometime this week and just see how you do on that. It's time you need to start reviewing on your own, and AP exam multiple choice test online. It's really nice because it'll help you figure them out if you need to, and it'll let you make corrections. You can go through the whole thing and try it and see how many you miss and then just go back and fix it. But it's a really good thing to look at. And on that same website, it'll teach you how to do stuff too. So be sure you do your reading, do your homework, and then you can start on the AP exam multiple choice practice test online. So there's all kinds of other things that you can look at and start working on too to help you. Practice makes perfect. Thank you much.